Welcome back to Retro Depot. Today we're going to be talking about FPGA boards and programmers. So we've done several videos on designing code, designing circuits in a schematic editor, converting over to VHDL and being able to import that into Quartus. But what happens after you get it into Quartus? You got to put it somewhere, and obviously uploading to a FPGA is the end goal. So if you're like me, a lot of times you like to prototype things out, but a lot of times you just don't want to mess with prototyping things out. You can use a PLCC adapter here to be able to go and hook up a perf board solution, be able to test out your code, but that's a lot of work, and sometimes, especially for smaller elements, you just want to make sure that it works the way that you intend it to do. It's not that you're planning on necessarily building your entire circuit and testing the whole thing, but you want to prototype out to make sure that certain sections of your VHDL actually work the way that you want them to. The easiest way of doing that, believe it or not, is just getting a cheap FPGA board or CPLD board. Now, I prefer FPGA boards, and the reason for that being is pretty straightforward. It's because with the code being uploaded the way it is, you can program these things serially, and they are not going to use that code. It's going to store it in memory, and whenever you power it off, it will just revert back to whatever code you have on there. So you don't have to worry about the life of the product, whether it being 100 or 100,000 writes, whatever it may be. You run into this program with PLDs quite a bit. Sometimes you need to check your code on the PLD, and you may only be able to program it a dozen times before it's just burned up, and those components are getting harder to find. And it's going to be the same thing with CPLDs before too long, because all the CPLDs that are in that were in mass production for 5 volt, they've already ceased. They're end of life. They're obsolete technology. So those things are going to start drying up in the following years, especially with hobbyists like us that are using those to implement in their own projects. So we need to find another way of being able to test our code so that we're not ruining these chips that we're eventually going to run out of. And that's where FPGAs come in. You can buy small FPGA boards from anywhere between, let's say, $15 to $100, depending on how elegant you want to get with your board. But we're going to talk about them for a little bit today, as well as the programmers that are associated with those. Now, full disclosure, I only use Altera, and there's a reason why I only use Altera. It's because it's what I was exposed to when I first started playing around with CPLDs and FPGAs. So it's just what I know. I'm familiar with the Quartus software to an extent. I'm not familiar with Xylinx or any of the other manufacturers of CPLDs or FPGAs. So if you're looking for something like that, there are lots of other videos out there. I would suggest that you Google it either and find websites that have information about those, or alternatively you can just search here on YouTube, and you should be able to find plenty of information on how to use those particular products. But today we're going to start off with a few. I've got a couple over here, but the first one I want to talk about is this little board here, and I'll give you a close-up of this. This here is a Cyclone 2 FPGA board, and they're cheap. You can find these for anywhere between $15 to $20 on eBay. Probably most of them are going to be in about the $17 to $18 range, and I'm going to show you here in a few minutes where we can find these at, whether it be eBay or AliExpress or any other website that lots of sellers from China are on, because let's face it, China is king, especially when it comes to these cheap electronics. But what I've done with this board rather is I've actually hooked up a Wemos D1 power supply board, which is a USB to 5 volt to 3.3 volt converter plus battery charger. Pretty straightforward little kit, but it's really handy in this particular sense because I wanted something that I was going to be able to supply 5 volt power over USB. Now, this FPGA board does come with a barrel jack, but as I've explained in several other videos in the past, I absolutely hate barrel jacks when they are 5 volt power inputs. I think that the only time that you should have a barrel jack is if you have some type of DC or AC to DC converting going on from, or somewhere in between your main circuit and your barrel jack. And the reason for that is pretty straightforward. If you're anything like me, you may have 30 or 40 wall boards, each with the same style of barrel jack, but you know what? They all have a different voltage. You'll have some that are 5 volts, some that are 7, some that are 9, some that are 12, some maybe 18, some maybe 24, some maybe 32. And unfortunately, it is a real hazard to be able to grab the wrong one, plug it in. Yes, don't give me that crap about, you know what, you should check to make sure you're plugging in the right one. You know what, it's too easy to get it confused. Too many people have blown up stuff. They need to standardize it. A certain size for a certain voltage, period. And I'm a firm believer of that myself. But rant over. But I really like this board. This board here, I've had it for many years. You can upload a couple different ways. It will either store the information. Actually, yeah, this one will store the information for you if you actually write it permanently, or it will just upload it into kind of the RAM, and it'll reset once you're done with it. But it's real handy. It's got a little breadboard here. Like I said, I don't have much in this. I think it was about $20 for the FPGA board, less than $1 for the power supply module. I think I may have had another $1 in this small breadboard here, and then I had maybe 10 cents worth of PLA that I 3D printed a case out of, along with probably less than an hour's worth of print time. There's nothing elegant about this setup, but this allows me to test code, and I can hook up a circuit right here on the board with a couple jump wires, and I'm good to go. And we'll take a look at some of those listings right now. So here's the first Altera FPGA board. It's pretty cheap. Like I mentioned before, you're going to spend anywhere between $15 to $20. I'll leave a link to this below. It is going to come from China, so you can actually get a better deal if you're willing to go over to AliExpress. But if you aren't really sure about AliExpress, or you just don't like that service, or anything about it just makes you uncomfortable, you can pick it up here. Like I said, this is a pretty standard board. You know, lots of people have used this for various different projects, and for the money, it's not a bad buy. It is very minimal though. And of course, it tells you that right up front, minimum system learning development board. So you're not going to get a whole lot out of this. And of course, if you wanted to take a look at AliExpress, like I mentioned, you can get a lot better deal on these. You know, this one here, of course, $9 shipping, that's not any better of a deal. But you can look through here, you can try to find ones that have a good sell rate. You might have to do a little bit of searching to find one that's going to be a little bit cheaper, but my guess is you're probably going to end up spending anywhere between $15 to $20, but you might be able to buy, you know, 2 or 3 of them at a go through AliExpress and get a little bit better deal. For example, here's a lot of 10 pieces for $137.75 with 3 shipping, but I doubt any of you are going to be buying 10 of these in one go. But they've also got a couple different variants here. So here's one that's just a little bit different. It looks like it's even got a power switch, but for all practical purposes, it's about the same type of board. So now, what if you want a little bit more elaborate design, something that is not just a FPGA with some headers, so that you can, you know, test a few things, whether it be VGA or, you know, S-video or whatever type of circuit you're trying to build up. Another good solution is actually going to be a surplus option, and that's the Altera University Program boards. Now, these boards vary quite a bit from, you know, time to time. I bought 2 of these boards for less than $15 a piece. I think I got both of them for about $13 to $14 each. And they are very handy. And of course, these are designed for the Max 7000 series, the EPM 7128 SLC 84s. But the interesting thing about them, and I have not used this feature, but they also have a Flex 10K chipset on them, which my understanding is another FPGA / CPLD hybrid. My understanding is it's a large array of just logic gates that you can use to implement certain things. But these boards are real nice because they are fairly cheap. They have some other things going on. They do have 12 volt inputs for the barrel jack. Yeah, 12 volts. Although the thermal characteristics of this board are horrible. It does use a 7805 linear regulator, and it gets hot. It gets very hot, so you will burn your hand if you leave this thing connected for any length of time. But you can hook it up to where you can either program the CPLD or the Altera Flex chip. Of course, it's got buttons, it's got LEDs, it's got dip switches, it's got some, hex displays here. It's got some indicator lights. It also has a place for both VGA as well as a PS2 connector. So it's got a couple different options on the board, and of course it's got these little female headers here that you can hook stuff up to. It's got some places to solder them in on this side of the board, but I've never gone back and done that. And the board is actually pretty robust. It's just on a couple of these little metal feet. Probably ought to mount this on a board of some kind. That way it's a little bit more stable, but it works for what it is. And these things right now, I've taken a look on eBay, and they're getting a little bit more expensive. I think most of them that I've seen are $30 and up. But like I said, if you catch these things at the right time, you can get them for as cheap as about $15 a piece. But it really depends on the market that's out there at the time that you're looking for one. So I'll get on there now and I'll show you a couple of those, and kind of let you see what's out there on the market for it concerns these types of boards here.
Now, I've also taken a look at the Altera University program boards here. They've got a couple different options on here. Like I said, they're going to be anywhere between $30 to probably $40 a piece. The interesting thing is you can find ones similar to this, where if you actually take a closer look at it, you've got the board, which is the same board, but it looks like they've taken the byte blaster as well as the power output and an on and off switch, and they've actually run that out and stuck it inside of what appears to be either an acrylic box of some type, or maybe it's an off-the-shelf Rubbermaid style box. But there's definitely these options out there that are going to allow you to have other boards. Like I said, colleges use this type of stuff all the time just to be able to teach their students VHDL. But you can get a couple different variations of this. Here's another one that looks like, I think this is a little bit newer style board. Yeah, so this is 2002. Mine is a 1998 version. Now, most of these, I will note, see this little DIP 8 chip right here in the blown up window, the one that's missing? That is actually your flash chip for the Altera Flex, because much like an FPGA, it uses a little flash chip, and of course you can find those online very cheap. So I just thought I would share that with you.
Now, the last FPGA board that I want to talk to you about right now is actually going to be this here. And this here is a nice little kit that I ordered from China. I cannot remember if I bought this on eBay or if I bought this on AliExpress, but it was about $50. But it really is a nice little kit. Now you get it with this little acrylic faceplate cover that goes over the front of it like such. You also get a USB blaster, which we'll talk about that here shortly. You get a USB cable and a couple other small things like a little controller here for the IR controller that's built onto the board. Yeah, it's got an IR module right here. And this is a really nice little board. If you've got the $50 to spend, I highly suggest it. It's made by a company called RZRD. And I will be straightforward with you, this particular FPGA board is nice, but the documentation on it, yeah, it's a little bit gray market, if you know what I mean. I found a couple pinouts for it, but you can obviously search that up yourself. The good news is that most of the information on the breakouts for this little central pin header here, that is actually very similar to this board here, how this one has the pin headers that go around it. This one has essentially the same thing. And that's very nice because you can actually build up a circuit and stick it on top of this and then interface that way. But it also has a lot of built-in components here. For example, it's got some switches, it's got a hex display here, it's got PS2 as well as a DB9 for like RS-232, as well as a VGA connector here. It does have a IR controller here, and it's got some built-in memory on this board as well. I'm not sure what the SRAM is. HY57V641620 FTP-7. So I'm sure that's pretty standard SRAM there. But it's got a USB power as well as a power switch here, so you can turn it on, as well as a reset button, which that's always nice. And it's also got a little piezo, a beeper right here in case you wanted to do some beeps and bloops. But yeah, it's a really nice board. I really like this one a lot, and I don't use it as much as I should, because realistically something like this would be if you were going to be doing like a pick and mix, like a Grant Searles single board computer. You could build it up and actually put it in this, and it would have pretty much what you need right here. And you just plug this into a backplane of some kind, and you've got your VGA, your serial port, as well as your S-Video. Do some type of internal mod here for the SD card. Real simple to build it up, and yeah, pretty neat little board. It's only $50, so you can't really go wrong with something like this. I really like it, but I'll get it on the computer now, and I'll show you where you can pick this thing up. Like I said, there's a couple different places you can get it from.
Now, if you want to go a little bit more expensive and get something that's a little bit more full-featured, they have a couple different options similar to this on eBay. And of course, they give you a general pinout, or well, at least what you're looking at as far as features of the board. There are a couple places online where you can go and actually find the pinout for what goes to what. It doesn't look like they have it here. We may have it down here in the description. It's hard to say. No, it doesn't appear that they do. But like I said, you can find these at several different places throughout the web, and they're fairly cheap. Of course, it depends on which one that you get, but you can get models with built-in LCD displays, USB modules. They've got various different modules that you can get to add on to this, and of course they just attach through that header there, like I've mentioned before, and provide different breakouts and things like that. But it really is a neat system, and if you're looking at trying to do something more in depth, for example, build your entire system from FPGA, this is really just a good option. And of course, if you're looking at AliExpress, there are options for these types of boards as well. A couple different models, like I mentioned before. This one doesn't have quite as much stuff on it. Mostly just looks like video and serial port, and yeah, really that's about it. It looks like maybe an LCD module there and a couple pins to break out, but you're not going to have as many features. Of course, you could wire up an SD card to this, and probably a PS2 keyboard port and a couple other things, but that would be enough to get you started if you wanted to start with something a little bit cheaper. And of course, they've got various different versions up here. You could obviously look for anything even remotely similar to this, and you're probably going to end up finding lots of different options on here. Some even smaller stuff here like ESP32 kits. AliExpress is really a great place to go for these little modules and junk throwaway electronics, but they also have some other stuff that's pretty neat. Looks like they even have some 3D printer boards here. But yeah, if you haven't ever checked out AliExpress, I use it, but yeah, it's got its downfalls. I try not to use it unless I have to, but it is a fairly decent place to go and get electronics from.
Now, the next thing that we're going to be talking about is programming, because we have to be able to upload our code to the FPGAs and CPLDs somehow. The easiest solution you're going to have, especially if you buy something like that last kit, it comes with a USB blaster. But you can also buy these things. They cost anywhere between a couple dollars to about $10, depending on whether you buy it from China or buy it from somebody here in the United States, whether you get it off AliExpress or on eBay. I'm going to show you here in a second some of the locations that you can purchase these things from, but they're very simple. They just have, you know, a little ribbon connector on the back with an IDC plug, and it's got a little micro USB connector on the other side. These things are in a very generic little case that you see for lots of different components. You know, it's got a little board on the inside and there's nothing to it. But these are all clones. These are not the actual USB blaster. Those things are a little bit more expensive, but they're pretty cheap still for these little things, and they work well. The only issue that I've had with these is if I decide to put my computer to sleep and turn it back on, a lot of times it won't read the USB blaster, so I'll have to do a full reset before I can actually upload any code. Another option you have if you're a dinosaur, like I am in many ways, is the Altera Byte Blaster. Now, this is getting a little bit ancient now. I'm assuming that as long as you're using the older software, it would still work. I don't know if it works with modern parallel ports or parallel port adapters, you know, the USB parallel port adapters, but literally that's all it is, parallel port to a JTAG. So real easy to interface. You can get these pretty cheap. Probably not going to have much support with it with Windows 10, but I don't know if Quartus software still recognizes this stuff or not, but especially if you end up getting one of these university kits, chances are it's going to come with one of these. So that's a nice little addition to have for that. And of course they program the same way. The only difference is one's parallel port and one's USB. So I'll pick out a couple of those and we'll take a look at those here in just a moment as well.
And of course here we have our USB blaster. This is obviously what you're going to need for programming your FPGA or CPLD in most cases, especially if you're going Altera. However, like I said, there are various different options out there. This one is actually from North Carolina. It's not a bad deal. It's only $7 and it comes with free shipping. So it's here in the States, and it's a fairly cheap price, although you can get these cheaper if you're willing to purchase them from China. And of course, if we take a look at AliExpress, you can see we can get these things for as cheap as about $4. So about half the price, but again, you're going to be waiting a very long time for these to come in the mail. Probably take anywhere between, I'd say, 3 weeks to about 2.5 months, especially for the cheaper ones. The cheaper you go, the more likely it is that these things are going to take longer to get to you, just simply because, yeah, just like everything else, you kind of get what you pay for. But these things are fairly reliable. I haven't had any problems with them so far. I've got 2 or 3 of them, and they seem to work. Now, if you go on eBay and you search for Byte Blaster, you're probably still going to get some of the USB blasters popping up here and there. Looks like a couple PCI cards. But if you scroll down, I can almost assure you that you're going to end up finding some Byte Blasters. The interesting thing about this, though, is if you end up having to buy one of these things instead of the USB blaster, you're going to end up spending more money than what you would on a USB blaster. So it really doesn't make sense to use one unless you just need it or you just have an older system that doesn't have access to it. But that said, you know, it should be compatible because the JTAG is essentially the same. The big difference is you are going to be uploading a POF. So as long as you can upload a POF file from JTAG via either Byte Blaster or USB Blaster, I think you'll probably be okay. There may be some protocol differences, but yeah, I think that your best bet's probably going to be to go ahead and just use a Altera USB Blaster clone. The last thing I want to talk about here is going to be the Xylinx Programmers. I don't use Xilinx boards. I've got a couple of boards that have Xylinx FPGAs on them, such as the SD512 for the MSX computers, but I don't actually use these CPLDs myself. They are good CPLDs. They've got 5-volt outputs, and of course Xilinx has their own FPGAs. Some of them even have onboard processors, but again, it's just not what I use. I don't know much about programming these boards, but again, you can buy the cheap Chinese knockoffs of their programmers, and of course, you know, if you want to go over to AliExpress, you can find the same thing, maybe a little bit cheaper, but again, it's going to take a little bit more time to get to you. But you can also buy their programmer boards. They've got some very similar boards here. This is a Spartan 6 core. You know, same kind of breakout, along with a JTAG header and a that's probably a 5-volt in plug, or maybe it's, does that have, yeah, it looks like it's got some those 1117s. I bet you those are 1117s. Little voltage regulators for coming up with the core voltages. I'm not sure what the Spartan 6 uses, but yeah, like I said, you can pick up stuff for various different computers and FPGAs, and it's going to be one of those things where you pick a company that's got an FPGA, you're probably going to be able to find some type of development board and programmer kit from China that's really cheap.
Now, you might be wondering which board you should actually pick for a given application, and that's takes a little bit more consideration. One of the big components that you'll have to think about is what you plan on doing with the board. So if you plan on just toying around with VHDL or even digital, and you know, just testing things out, then a small board like this will probably do very well. This is actually the board that Grant Searle used for his pick and mix Z80 computer, or 6502, or you know, whatever. This isn't a bad solution because it's got a lot of logic blocks for what most people are going to do with an FPGA. The downside to this is that you can't take this FPGA off of this board and put it in something else, but it does allow you to at least prototype and do some, you know, other small things. Now, if you were getting to the point where you wanted to start implementing CPLDs, I highly suggest that you look at the Altera University Program Boards, because they are quite handy. Again, it's just got a socket here, and of course the socket's not filled. The actual CPLD is here, and I've got tons of those things so that I can play with them and, you know, take them out and stick them in other projects. So something like this is a little bit better for an application like this, or if you don't want to have a dedicated programmer board so that you can program this, or you don't want to add in the JTAG header on your projects, having something like this is really nice because you can program on this board, use a PLCC puller, pull the chip, stick it in your project, and go. And it also gives you some bare minimums here so that you can, you know, play with things like VGA or you know, PS2 connectors, whatever it may be. But it's a real nice board, but you got to remember that there is a difference between CPLDs and FPGAs. Generally speaking, they have a lot of the same applications, but FPGA is going to give you a lot more than what a CPLD is going to do. CPLD is an in-between between a PLD and a FPGA, really. It's, you know, where a PLD is going to give you a very small amount of programmable logic, enough to do, for example, let's say memory decoding or something along those lines. A CPLD is going to be able to have more complex functions internally, whereas a FPGA is more designed for doing almost complete systems. So you wouldn't, for example, try to fit Grant Searle's pick and mix on something like this. You would use this for, you know, let's say generating VGA video or composite output. There's actually a really neat project where a guy completed the entire ZX Spectrum circuitry minus the memory and the Z80 into a CPLD. As a matter of fact, this very same CPLD, I'll put a link to it below because it's a really cool board. But the idea is to fit a ZX Spectrum inside of a ZX81 shell. So that's a really neat kit, and I've been wanting to get one of those from him. It's the same guy that did the Harlequin clones. And of course, I don't know if I've done a video on those or not. I think I've uploaded a couple pictures, but I don't think I've done a standalone video on it. I need to actually do that. But really neat kit. But yeah, you would do something like that with a CPLD like this. But if you wanted to design, let's say a computer, all in a FPGA, I would highly suggest going with something more full-fledged like this. Of course, again, your application is going to be a driving force behind this. Are you actually wanting to develop a system on a chip? Or are you just simply needing some complex functions? And I think that's the big difference between when you might need a CPLD or an FPGA. If you just want to drive complex functions, a CPLD is probably going to get you there, some type of interface to a piece of hardware that you're trying to develop. For example, let's say going from a Z80 or 6502 computer to be able to drive, for example, an SD card or some type of IDE interface along with a memory controller and things like that, a CPLD is probably going to get you there. But if you're wanting to combine, let's say, a VHDO processor along with some of these complex systems, you're probably going to want an FPGA. And I hope that helps you figure out whether or not you actually need one or the other. But that's it for today, folks. I hope you enjoyed the video. If there's any questions that you have, as always, please post them down below or contact me via the website. Like I said, I do have the contact form there. Go to retrodepot.net, click the contact us in the menu. It'll bring up a little form fill. You can type your questions out. It sends me an email directly, which then I can respond to your own email from. So that's really handy. Check that out. Also, like I said, if you've got any suggestions for videos, I'd be happy to hear them. If you have something that you would want me to take a look at, for example, your own computer or project that you've designed, and whether you're selling kits for it or you just come up with it and you think it's cool and want somebody to put it out there in the limelight, I'm happy to take a look at it for you. I'll even shoot a video about it for you if if it's something bigger that kind of deserves a little bit. If it's just a couple small little things, hey, I can't get this to work, contact me separately. I'd be happy to talk with you about it, see what it is, and we'll see what we can do. But always happy to take a look at other people's projects. This is a community. It really is. And I've been fortunate enough to have a lot of that given to me, and I want to give some of that back to the community now. And that's another reason why I'm shooting more videos this year than what I have in previous years, because I really do want to give some of this information back and some critiques back, because I've gotten those and they've really helped me get where I am today. And of course, I am an amateur. I have no formal training, so most of what you see here is me learning things on the fly as I go along, storing that in the memory bank and then being able to regurgitate it later on for whoever may want to have that information. So again, I'd like to thank all of you for paying attention in the video today. Again, if you have any questions, feel free to post them below, and we will see you next week.